So let's continue. So these that will be, yeah, so I have explained you everything. So you can go through again. So also in generally, okay, in any, so in general form, they say, so what if it is both are involving? So far we have seen in this side what for the DABA or DABA X terms up to N terms. Okay, here what is DABA or DABA Y terms up to N terms. Okay, what if both are involving? Like for example, DR and D dash Z. Okay, so in that sense, sorry, this should be S, I think, not square. Okay, so what if DR DS, I mean DABA R of DABA XR times again, okay, and again DABA of S over DABA YS, okay, of Z, okay. So you know these both are same, no? So in that sense, they have written DABA R plus S. If it is, let's say, A time R time A time S is what? So if this is a law of exponential, isn't it? Power. So if the same base is multiplied, we can add the exponential. I mean, yeah, power. We can add the power, isn't it? So in that sense, they have written this way. Okay, also Z is there. So here down part we can both are different case. So DABA X of R into DABA Y of S. Okay, that's what they have written. So it should be S. So you can see some common thing. So in the D terms, if it is something Dn, we have Mn. No? So in that sense, so DABA R over DABA XR. So in that sense, we have M of R, okay? But D dash of N, we don't have M or anything, only one, constant is one. So we don't have for that one. So pi of R plus S, Y plus MX. So they have written from these two, okay? From these two, they have written a common one for the, what if it is two different case comes, I mean D dash, okay? What if dr and d dash s comes? Okay, since why we are doing this one, because in our equation number 1 we have everything. I mean the nth order homogeneous equation, we have DABA n over DABA xn there, and DABA x DABA y over there, and DABA y n there. Okay, so that's why they are finding all to make it in this form. Okay, then substituting these values in equation number 2. So what is the equation number 2? So it means the our LHS part. That's what we take as the equation number 2, no? So wait, I will show you the equation number 2, which is this one. So you can see we are taking only the, this is our main equation. We are taking only the LHS part. Okay, that part is we using for the complementary function. So in that we are going to substitute the values we have found. Okay, let's substitute these. Let's see what we are getting. Okay, this one. Okay, so whatever the d terms and d dash term, they are substituting these values. Okay, so a naught mn, a1 mn minus 1, you just substitute these again in the equation number 2 and see whether you will get this equation. Okay, pi and ymx will be, from this you can get as a common one. So they are writing all the coefficient as a common one. Okay, so you can take this as a common one. So these are the remaining like a coefficient which is equal to 0. We are taking this as a equation number 9, where which is true if m is the root of the following equation. Okay, So if it is if we are having something, let's say a and x equal to 0, okay, so it will be if x not equal to 0 or a is equal to 0 and x also is 0, no, or so that's what they say. If the m is the root of the equation, it is true. Okay. Okay, now let's continue. We are still here. We are almost finished. Okay, let's finish up. Okay. So you can see then. So if it is like what I said, ax equal to 0, the possible case is a is equal to 0 or x is equal to 0. No, sometimes not equal to 0. Okay. So the coefficient they are taking as equal to 0. So that's what they say. They are taking this one, pi n or something. They are taking this entire as a coefficient as equal to 0. Okay. So this is the equation number 10. This equation number 10 is known as the auxiliary equation, A. Okay. For the case of PDE solving, we call this one as the auxiliary equation. You also have gone through in ODE as well. Okay. And hence the equation 1 and is obtained by putting, okay, then they are making one suggestion. From the auxiliary equations, for the equation number 1, they ask you to put wherever the d as m and wherever the d dash as 1. In the case of the function, I mean pi d comma d dash is equal to 0. Okay. Okay, there are some cases. So after that, you put m is equal to 1. So this is the auxiliary equation case. D is equal, you substitute d is equal to m and d dash equal to 1. Okay. So then our equation will be changed into something no, like m squared plus m minus 4, something like that. Okay. So let's see how our auxiliary equation will change according to the m value we are getting. I mean the root of the m change our solutions. Okay, so you can see there are some cases. Okay, we gonna see some like 3 cases. Okay, so case number 1 says, so if you get all these m1 m2 mn values are n roots of this auxiliary equation after substituting these values. Okay, then the following case has, if all the roots are distinct means, for example, I have the m value 2, 3, 2, minus 1, 5, something like that. Okay. In that case, wherever the our solution in this form, no, phi of y plus mx. Okay. So this can be any m. Okay. So the answer will be, for this case, we have the complementary function will be something phi 1 y plus m1x. Okay. Plus phi 2. These are arbitrary functions. Okay. Y plus other m. I mean here, let's say 3x. Okay. Here y plus 2x. Okay. Again phi 3 will be y minus x. Okay. Again y phi 4 y plus 4x. Okay. I mean 5x. Okay. So this is if it is all the m's are distinct case. Okay. So where this phi 1, phi 2, phi n are arbitrary functions. This is our case number 1. Okay. So let's see what if the case number 2 says auxiliary equation has some repeated roots. So repeated root means something like, for example, I have the answer m is equal to 3, 2, 2. Okay, so these two are repeated, no, same coming. So in that sense, you don't need to write this like a separate one. What they said is your complementary function will be just equal to 5. The first case, you don't have the repeated one. Let's say all are repeated. Okay, they say all are repeated. For example, 2, 2, 2. This is my answer. Okay, so complementary function will be phi 1 y. Okay, yes, y plus 2x. Again, I have the same repeated now. So what you do is you have to do phi 2 y plus 2x. Since my same m come, we can multiply x terms. Okay, that's what they say, x times. Again, what about the next one? You will have x squared, isn't it? X squared pi 3 y plus 2x. Similar way, okay? Okay, that's what they say. If you are having all our repeated roots, all the m1, m2, mr, im, then you can write I1, this one, plus x time, next one x squared, up to x to the power r minus 1. Since we are having r, since we are taking one here, x to the power r minus 1. So here we have three solution. So we are going up to x squared. Similarly, it is r solution. We will go up to x r minus 1. Okay. So here also these are arbitrary functions. Okay. Have we got that? Okay. Now let's go for the case number 3. Okay. So case number 3, if you have the complex roots. Okay. So complex roots in the sense sometimes you may have something, for example, let's say plus m minus, what you can write, for example, plus 2, which is equal to 0. Something we can't make it as a, coefficient. Okay, in that case, you have to use like minus b plus or minus square root of delta divided by that one, no, 2e. Okay, this formula. So sometime if you are having, let's say, in the square root, you may have something 2i, 2, minus 2. Okay, let's say. So you have to use the idea of complex number, no? So complex number I is equal to, square root of minus 1, no? So you may study this later. Anyway, just for the, note, okay? So I is equal to minus 1. So for the minus 1, you can write this one I. Maybe some 3 plus 2i. Okay. So what if you have plus or minus, no? Since you have two solutions. Okay. So what if you have the complex roots? Okay. This, if you get like this, we call this one is not a real one. This is our real part. This is our imaginary part. Okay. It means there is no such number in reality, but we are taking for our calculation. Okay. This we call as a complex roots. Okay. Let's say our roots are alpha plus ip. Then the corresponding will be wherever m, you have to put pi of, let's say pi 1 plus, for the m, you can put this plus value of alpha plus ib times x, and plus next one will be y plus the other value. Alpha minus ix. Okay. So again, these are functions. So these are very easy for you to remember. Case 1 and 2 and 3. Okay. So that's all about the case of complementary functions. So let's see one of the note. Okay. So it's not a big thing anyway, but it may happen in some cases. Okay. That's why they have included. So one of the notes says, if we find, okay, let's say one of the case comes in the equation number 1, sometime you may have a naught is equal to 0. So if a naught is equal to 0, go through the equation number 1. What will happen? You don't have this part, no, xn. Since this is 0 times this one, this term will be vanished. Okay. We have other term. Okay. But we have some other a in there. Okay. So it means we don't have the d nth term since of a naught is equal to 0. So it may happen sometimes. Okay. Not always, but sometimes. Okay. But if it is in case, it is advisable to obtain the auxiliary equation by putting. Okay. So far what we have done in our, if you have all the A1, A0, A1, A1, A2, all the AIs are there, we take D as M and D dash as 1, no. But if this special case comes, you take d as 1 and d dash as m, because we don't have this part now. So they are saying to switch the m and 1. Okay, d is equal to 1 and d dash equal to m. And again, we have the same kind of things. Okay, so in that case, the complementary function will change into, see here, what is our actual complementary function for this case? This case, we have pi 1 x plus, sorry, y plus mx, no, mx, m1x, pi 2 y plus m2x. So since we are taking this in the swept way, d dash m, d is equal to 1. See here, the y plus mx here change into x plus m1y. Okay, x plus m2y, x plus m1y. That's a small things. Okay, so here m1, m2, mn are roots of the auxiliary equation. So if it is comes in your any examples or anything, you use this procedure. Okay, not a common one, but if it is comes. So only things you have to keep in mind, wherever a not is equal to 0, so you can use this part. Okay, that is one of the note. So hope you have understood about how to get our complementary function. So we can also see some I mean, examples. Okay. So what about the particular integral case? So let's see the common particular integral cases. Then we can come to our easiest part. Okay. So I mean, particular integral of this kind of equations. Consider we have actual equation is, let's say f of d comma d dash, we are taking as a capital F x comma y. So then they are using an inverse operator. Okay, so they are using, so our pi will be, which is equal to 1 over f of d comma d dash. It means what? Whatever the equation they have given, you will substitute d and d dash now. That equation you have to write here. Okay, and then times this part. This I can write as a RHS. Okay, so I'm going to take as a RHS. So that RHS you have to multiply. Okay, so not only that, we have some rules also. Okay, we can see. So you have to keep in mind we are using this inverse operator times RHS, whatever the function they have given. So in terms of this function, the solution will be changed. Okay, so that's what we're gonna see. Okay, I will show you something anyway, but I will summarize it, okay, later. In these notes, this is a book note anyway. So they have given something. I don't know how much you can understand this part, okay? What if it is RHS equal to e to the power x plus dy, okay? So you have to use this one. So I will send these notes anyway, okay? So you can go through, but I will make it easier for you, okay? So let's stop this one here, and I will summarize the actual things, okay, until for some time. So let me take the whiteboard. Okay, let me summarize what we have studied so far. Okay, on the chapter 3, we have started our homogeneous PDE with constant coefficients. So okay, linear, okay, linear as well. Linear homogeneous PDE with constant coefficients. Okay, so we have okay, so if I write this one, a node da by node z da by xn. So this is a general equation of nth order homogeneous equation. So x I mean n minus 1 da by y. So you can write this one up to, we're gonna go a n da by nz over da by yn is equal to let's say f of x comma y, any function of x and y. So this is our equation. So since this is equal sign there, This is the equation. Okay. Also, these are the coefficient. We are taking all as a constant one. Okay. Also, you can see this is the nth power, nth power, nth power. All terms are n power. Therefore, it is a homogeneous. Okay. Also, you can see all the powers are 1. No degree. Degrees are 1. So, you can say this is a linear as well. Okay. That's how you have to find out. So, if you get like this equation, the complete, general solution of this one, we will have in the equation complementary complementary function plus particular integral. This is our general solutions equations. So how to find the complementary function and then the particular integral is our cases. Okay. Okay. I will continue. Okay. Let's define some general. Hope you are writing with me. Okay. Or you can take some screenshot. General working rule. Okay. In the sense, first of all, we have to find out whether it is linear, homogeneous, as well as constant coefficient. Okay. That is our first case. Second rule is you have to make this into the symbolic form. Okay. So what is our symbolic form? Wherever the daba over daba x, you take as a d. And then daba over daba y as a d dash. Okay. And then make the entire equation. Let's say this equation number 1. Okay. That 1 can be written in the symbolic form of, let's say, small f d comma d dash of z is equal to this one. Okay. And then third one, you have to make it is a auxiliary equations. Okay. What is auxiliary equation? You have to put, so here also you can say put. Okay. Put where the d is equal to m as well as d dash equal to 1 to make it more simpler. Okay. I also explained you what if the case of a not is equal to 0. Okay. I'm not going to use here anyway. So our equation will change. This equation has changed into wherever d, I'm going to put 1. For the d dash, I'm going to put 1. Okay. Which is equal to, yeah, since this we are talking for the complementary function, so this will be changed into f of m comma 1 is equal to 0. Okay. And I don't have a place. Anyway, I am writing. Fourth one will be solving this auxiliary equation. Okay. And then fifth one will be, we write the complementary function. And sixth one, we find the particular integral. Then general solution will be this plus this. Okay. So this is how we're gonna find our answers. We're gonna do some exercises. Okay. So this is a working rule to solve the homogeneous linear equation. Please write down the steps. Okay. Now we will take the new window. Okay. So in the case of complementary function, we have analyzed 3 cases. What case of 1, case of 2, case of 3. Okay, you can go through this. Okay. And then particular integral case, we have some rules. Okay. So let's see some rules. This is also rules. Okay. In the particular, integral case, okay, first of all, you have to find the operator. Operator is equal to 1 over f of d comma d dash, isn't it? Time, whatever the RHS, okay, f of x comma y. So according to this RHS, we'll have some rules, okay? That's what we're going to see. So I will give you some idea, maybe see whether it is common for the ODE as well, okay? If it is different, let me know. So I'm not aware for now. the ODE cases. Okay, type of RHS. Okay, according to type of RHS, we have some working rule for PI. Okay, particular integer. So what if the case is, okay, fx comma y is equal to 0? I mean 0 case or constant. Okay, so the particular integral will be as it is. Okay, 0, or it is constant. Okay. Second case, what if fx comma y is equal to exponential of ax plus by? Okay, so in this sense, you have to put wherever the d comes, I mean the x coefficient, d dash, you have to put the y coefficient. Third case, what if a trigonometric one, sine ax plus by or cos? Okay, so I have summarized some here. Okay, you can see the list. I will send the note. It has some more. Okay, you can go through that one also. So in this sense, you have to put, let's say, so you may have d squared, that is will be minus this coefficient of a. Okay, I mean x. And then for the d dash squared, you have to put minus b squared. Okay, what if d and d dash? You have to put minus ab. Okay. Fourth case, you may encounter, so you can write down. So fx comma y is equal to xm yn. Any, I mean algebraic equations. Here you have to use binomial expansion. We can see if it comes. Okay, binomial expansion. So we can see what it is later. So there are some other cases as well. Not only this one, no, there are some more. So in that sense, you have to use some method. Okay, that means integrality. Like just check it out. This one, d minus md dash of fx comma y, which is equal to integral of f of x comma c minus mx dx. Okay, so let's see if it is encountered, we can use it. Okay, for now, just use these things. Okay, you can search some example yourself also. Don't depend on the notes only. Okay, you have to find some notes, extra thing yourself, then only you can score more. Okay, so first of all, let's do some example. Let's see how to find the complementary function for some cases. Okay, for example, just for the practice for the complementary function. Okay, okay, can you do this example and send me the answer? Okay, so let's see, let's do some complementary function exercise. Okay, first one, find CF of this one. Before making this one, you just do this practice. Okay, d dash minus 2 d dash square of z is equal to 0. Can you solve this and find what is CF in terms of pi? Okay, pi 1, pi 2. Can you find the answer? What is m values and just put the pi 1 value. So can you send me the answer? Because this is squared, so order 2, you may have only 2 answers now. So you can write this answer for me. Okay. Can you send this quickly? So I will allocate some people also. If they don't answer me, I will put here as the absentees. Okay, I would like to call some people. Okay, 002. Okay, 020. These people should send me the answers. Otherwise, I will take this as a absentees. let's say 049 086 130. Again, 100 and others also can, others send you answers, but these people should be send the answers within the 10 minutes. We have only 10 minutes. So you have to answer me quick as possible. Otherwise, I will take as absent. Okay, 1, 2, 3, 7 people. So I will allocate some more as well. Hundred and 18. Okay. So can you answer these people? Okay, where's the others? What is the answer? Just type your So what are the M value? Just send me the M value first of all. And then you can use F1 or something. No need to use pi. Okay, if you can't type the pi, just use F1. Okay. Yeah, what is the M values? Okay, I got one answer. Yes, your answer is correct. What about these people? 002, can you answer me? Can you answer me? What is M? I not only want your attendance, I want you to participate answering questions. What are the M values? Very easy question. Why you taking this much time? So for your information, we are take for the auxiliary equation, we take d is equal to m and d dash equal to 1, isn't it? So just substitute that. Sorry, d dash equal to 1. So this will be m squared plus m minus 2. So what is the, if you make it equal to 0, what is the factorization? That's the question. Then you can put pi 1 y plus what, pi 2 y plus what? That's the question. Why nobody answering? Okay, if anyone finish, do this question. Find the CF of d squared minus 2d d dash plus d dash squared, which is, I mean, z is equal to 0. Okay, good. So can you, okay, can you do this one? What about 049? 49, can you answer me for this question? What are the possibility of m? Okay, good. So can you answer me this m for 49 and 118? Can you answer this question? So others also you can continue. What if you have d4 minus d dash 4 of z is equal to 0? So you may have the repeated answer or complex answers. So in that case, how the solution will change? That's a thing. So there are only 3 cases. Okay, good. Is there only one answer? So if, since it is a d squared, no, so you can't write m is equal to 145. You have to write, if it is same answer, it should be m is equal to 1 comma 1. Okay, so don't write only one answer. Even though it is same answer, you will have two answers. No? So that's why we called as the repeated answer. Okay. Okay. 118. Can you do the other questions and send me the answers? Okay, good. What about the third question? So this is a question for three cases. Okay. So what if it is a distinct root? What if it is repeated root? What if we have, a complex root? Okay. So what about 0, 4, 9, 146, 150, 30, 86? Where are all these people? At least answer me what is the m values for question 1, 2, 3. So you can write the, solution later. Yes. So all others are absent. This 86, 130, 46, 50, 49. Our time gonna finish now. Okay. Make it faster. So we have 49. So since I started a little late, today I will take until 12. Okay. So if anyone need to go Moscow, anything, you can, if it is late, you can go. Otherwise, yeah, you can stay until 12. Okay. So since if I started late, I'm gonna continue one more time. Okay. So you can join again if the, it's fine. Okay. 86. Okay. 49. Okay. Okay. Do the other questions as well. 130, 46, 50. Can you show your attendance? Good. I hope everyone are working on. Okay. Okay. I'll take a new window. So in the meantime, others answer me. Okay. What are the numbers? 130, 46, 50. So I'm expecting your answers now. Quick as possible. Okay. If the meeting ends, please join again. Okay. 46. These people not yet answered me. Okay, the first questions I don't wanted to do anyway. So d square plus d dash minus 2d dash square of z is equal to 0, isn't it? So only thing is you have to use auxiliary equation d is equal to m, d dash equal to 1. So when you substitute this one, m squared plus m minus 2 is equal to 0. So possible values are, what are the possible values you found? Minus 2 comma 1, no? So our z will be phi 1 of y minus